Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I'm the director of the Planetarium, and with me tonight is one of the grad students who works at the Planetarium, and I will let her introduce herself.
Hi, I'm Lindsay. I'm a physics graduate student at UMD.
So tonight is another edition of Ask an Astronomer. So we are here to answer your questions. So go ahead and start putting those down in the comments and we will get them answered. And in the meantime, Lindsay and I also have a couple of really fun things to talk about. And I guess I'm going to start because we've gotten one question from my mom. Hi, Mom. Wanting an update on Perseverance Ingenuity, and of course, I was planning on doing that anyway. This is the first thing that I was going to talk about, so I guess, Lindsay, should I just go ahead and straight do that?
Yeah, yeah.
All right. So let me. There we go. Uh, so cool stuff from Percy and Jenny. Ingenuity has made 8 successful flights so far. She was originally only supposed to do, I think, 3 or 4, and everything has been such a success that they have extended her mission, and Ingenuity is now kind of sticking around with Perseverance. Perseverance has gone off to start doing the science that it's meant to do, looking around Jezero Crater, trying to find evidence of past water and hopefully maybe evidence of past life there as well. And so Ingenuity is kind of flying with it, scouting out some places for Perseverance to go, and also just kind of testing what it would be like to have an aerial companion to a rover and the kind of benefits that we would get from that. So Ingenuity here, it's shallow on the ground from its 8th flight. And then we've got this really cool panorama from Perseverance that's taken of this like outcropping in Jezero Crater. And geologists and astronomers, or astrogeologists, because we have that, are super excited because the features that we're seeing here do support that there was flowing liquid water here. And this is the reason that this site was chosen. We thought it was an ancient lake bed, and that is a really high potential area that life could have developed. And that's why Perseverance is there. So seeing this evidence that it was actually a lake bed, and getting started with Perseverance science missions, we've got some really great stuff coming from it, and I am very excited. All right, it looks like we've got a few questions. So I'm just going to hop back to us and we'll answer those before getting to some other stuff. All right, so we have, how far away are the furthest objects our space telescopes can see? Well, um, th- when was CMB? 300,000 years after the Big Bang?
Yeah.
Yeah. So the furthest thing that we can see, which is literally the furthest thing that it is possible to see, is the cosmic microwave background. And that's the light that we see coming from that was emitted about 300,000 years after the Big Bang happened. So really, really, really early on in our universe, especially considering, we're 13.8 billion years old, the universe is right now. So right after it started. And that's the earliest we can see because before that, the universe was so dense that light can't travel through it and make it out to our eyes. So what we see as the CMB, the cosmic microwave background, is the first point in time where the universe actually becomes transparent and that light is able to freely move and make it to our eyes. So yeah, we can see as far back as the very first thing that we are capable of seeing, which
Yeah, so
is,
because of the way that light works, that first thing that we're able to see after the Big Bang is also the farthest away we can see. Light can only, or light's not instantaneous. It takes time to travel for us or to us. So that light that was created during the cosmic microwave background radiation that we see, we can't see past that because our universe is not old enough to see past that.
Right. So kind of crazy. All right. So next question. Years ago, I read a science fiction story about mutated humans who sailed ships in outer space powered by huge solar sails, powered by sunlight. Would this actually be possible? Yes. And it is something that is actively being worked on. Light has energy. When it hits something, it can exert a force. Now, it's tiny, but when you have lots and lots and lots and lots of photons, light coming from a star, and you have a big enough sail, that can produce enough of a force to actually push the ship forward. Now, it's not going to go very fast, and I forget what speeds are like. It's pretty slow going, but it is possible, and it's a method of travel that we are looking at for new spacecraft and things. I believe what's it called? The company that Bill Nye is with now.
Yeah, the Planetary Society.
Yes,
So
that's
they
it.
have a bunch of little tiny spacecraft that they're going to send out into space using those solar sails. And they think that with the light from lasers aimed at those sails, they might be able to get them to go to almost a quarter of the speed of light,
Oh,
which
that's
would
a
be
lot faster than I thought.
really cool.
Yeah, that's definitely a lot faster than I remembered hearing. That's cool. Awesome. Yay. Okay, so one more question we've gotten. What kind of extraterrestrial organisms would you folks like to find? I have a very simple answer. Any. I don't care. Single cell bacteria, alien fish, little green men. I just want to see that life of some type is out there. I don't know, Lindsay, if you have a different answer than that.
I just really want to see what is underneath the ice of one of Jupiter's moons, Europa.
Yeah.
I think that could be a really good place to look for life. And also to go back to Saturn's moon, Titan, and analyze that, because that has actual liquid on the surface of the moon. It's not liquid water, it's liquid methane, but things could live off of liquid methane.
Yeah.
So there could be living things there too.
And we'll add that that is two missions that NASA is already working on. They're sending a quadcopter called Dragonfly to Saturn's moon Titan because it's the only moon that has a thick atmosphere. It actually has an atmosphere thicker than Earth's, so you can fly in it. And Ingenuity has shown that we can fly on other worlds. And so Dragonfly is going to explore Titan a little bit more. And then I know they're working on the Europa Clipper, which is, I think that's just a data mission to get more information about the moon so that we can plan future missions to actually land and explore. So I'm hoping that with the private sector really starting to embrace space exploration and getting some really great momentum going, that this means it's going to happen soon. And by that, I just mean in my lifetime, because I want to see this so bad. All right. Well, those are some really great questions. Thanks, Honor. All right. Well, that's the end of the question list right now. So if anyone has any others, go ahead and leave them down in the comments. And I am going to talk a little bit about something else that's recently happened that's something you can actually get involved in. So if you don't know, NASA has a lot of these citizen science projects where anybody can look at the information and data that comes from telescopes and helps scientists find things. So one of these citizen science projects that's ongoing right now is the TESS Planet Hunters. So TESS is the Transiting Exoplanet Survey satellite that is in orbit looking for planets around other stars. And it does this by looking for a transit or looking for a planet crossing in front of its star, which causes the star's brightness to dip a little bit, to drop, because the planet is blocking some of the star's light. And so what TESS is doing is monitoring over 200,000 stars to watch for these periodic dips in brightness that could indicate that there's a planet there. And of course, you can imagine 200,000 stars, watching them for years. That's a lot of data. That's a lot of information to get through. And so they have partnered with Zooniverse and the citizen science project specialist to get anyone who wants to help out with it. And so what you can do is you actually look at the data after a little bit of training, which isn't much, just kind of showing you what it is you're looking for. You get to look at the data and mark it and tell them, hey, this looks like there's potentially a planet here. You should take a look at this object. And what's really amazing about this is citizen scientists have actually recently discovered 2 new planets within TESS's data. So these 2 planets are around the star HD 152843. Not interesting names, catalog name, but it's so cool. So they found these 2 planets orbiting around the star, and they were able to kind of mark that information. Enough people kind of marked this object as having the right kind of data to show that there's likely a planet there, and the scientists double checked it, took a look at it, and were like, hey, you guys are right. There's not only 1 planet, there are 2 planets here. Now, both of these are larger than Earth and orbit very close to the stars. So they're what we call hot Jupiters, although they're smaller than Jupiter. They're more like hot Neptunes. But it's still showing how beneficial everyone can be to this scientific process. You don't have to have a degree to make a significant contribution. So if you are interested in doing this for yourself, I have put a link in the video description to the Planet Hunters website, where you can do your own citizen science and help astronomers find planets around other stars. And who knows, you may help find the next Earth-like planet, which would be really awesome. And I know this is something that Lindsay also, we both love sharing with people, this just citizen science that anyone can take part of. All right, let me check. I'm not seeing any more questions in yet.
I do have a comment on the light cells that we were just talking about.
Okay.
So I was actually thinking about a different light cell project. So the one that you were talking about with the Planetary Society, that is called Light Sail, and it does have those kind of light panels that are hoping to power those spacecraft. I was thinking of a different one called Starshot, and it's a bunch of different little tiny versions of that light sail, and that's the one that they're hoping is tiny enough that when they hit it with a bunch of lasers, it can get to 25% the speed of light.
Okay. Still really cool.
Yeah. And they're sending a bunch of them towards Alpha Centauri, the closest star, so hopefully we can actually see maybe Alpha Centauri kind of soonish.
Yeah, I mean, Alpha Centauri is 4-ish light years away. So, quarter of the speed of light, that would be 16 years, give or take.
Yeah.
That's doable. And Alpha Centauri has a planet around it.
Yep.
So, to clarify, we're not talking about like human missions. This would be tiny little spacecraft. But still, being able to do that would be a huge first and would be amazing. All right, I think, Lindsay, do you want to talk about some of your stuff?
Yes. Okay, so there was a payload sent up to the International Space Station a few weeks ago, and the space station got some upgrades with its solar panels, and the new design is really, really cool. And also pay attention at the end because it talks about some of the new experiments that were sent up with the solar panels. And Jessica and I are particularly excited about one of the experiments that is now up in the International Space Station.
SpaceX and NASA are teaming up again to launch their 22nd commercial resupply services mission to the ISS. But this time, they're bringing along tools to give it a makeover. On board the Dragon cargo capsule is a massive solar array system that's set to transform the power capabilities of Earth's only international orbiting outpost. And in the process, it just may bring us one step closer to developing a viable power system for deep space missions.
This new power can help not only extend the existing life support systems that are up there, but just enable new station modules to come in and kind of extend the life of the station in general for everything.
So how does one get power 350 kilometers above Earth anyway? Well, right now, the ISS has 4 pairs of solar arrays that convert sunlight into electricity. Together, they cover more than half the area of a football field and generate 160 kilowatts of power during the day, half of which they store in the station's batteries for when the ISS isn't in sunlight. The first pair was deployed in 2000, with the rest following suit over the next couple of years. And while the arrays are still working okay, they were only designed to have a 15-year service life, and as a result, aren't as efficient as they used to be. In fact, they're lagging at just 14-something%. So yeah, it's time for an upgrade. Known as the International Space Station Rollout Solar Array, or iROSA, these lightweight and flexible solar arrays were designed by Redwire in partnership with Boeing to become the station's next generation power system. Using multi-junction solar cells, these arrays run at more than 30% efficiency and are about half the length of the legacy arrays.
ROSA, a new innovative flex blanket solar array technology that utilizes these kind of unique slit tube booms, and so that's pretty unique. It allows us to keep the design a lot simpler, a lot less parts, lower complexity, and it's really scalable.
On their own, each new solar array produces 28 kilowatts of power, but the plan is to send up 6 new arrays, which, when combined with the existing ones, will supply the ISS with up to 215 kilowatts. The best part, this modular design makes it super easy for the arrays to be packed in and out of a cargo capsule. The arrays use high-tech composite booms to roll out a solar cell blanket, just like a party horn unfurls.
A famous video, or at least famous for us, of the original ISS arrays deploying, where they were kind of sticking as they were deploying. It's a little scary to watch, and part of the array actually ripped, and they had to go out and repair it. So when developing ROSA, we eliminated a lot of those problems with how we're rolling the arrays.
After years of development, iROSA is finally ready to be installed on the ISS. Earlier this year, NASA astronauts Kate Rubins and Victor Glover, as well as JAXA astronaut Soichi Noguchi, prepared the solar array site with a modification kit. This means that the site is all ready to go for when the first 2 iROSA wings arrive in early June, on board SpaceX's Falcon 9 rocket.
We'll be there for about 2 weeks or so, and then the crew will come out on a spacewalk. And then the fun part begins where they translate this big solar array, all the way out in the thrust structure. They'll kind of slide us into place, and we kind of snap in with some pins, and then there's a handful of bolts that they'll install to kind of rigidly secure us down. They'll unfold the array, so they'll release a couple other bolts, and the whole thing kind of unfolds. With ROSA, there's no motors or anything like that. As soon as the tie downs are released that hold those, it's just going to start rolling out all on its own.
And if all goes well, the remaining 4 iROSA arrays will be sent up and installed next year. But the iRosa arrays aren't heading up to the ISS alone. They'll be joined by a whole cast of interesting cargo companions. A team from the University of Wyoming will be sending up tardigrades to see how they respond to the stress of living in space, while another team from the University of Wisconsin will be volunteering some cotton plants to study how microgravity affects their growth. After all, one of the main roles of the ISS is to support scientific exploration. Thankfully, the iRosa arrays will be there to make sure that the lights stay on for many more experiments in the future.
I think ISS is one of humanity's greatest achievements, having this massive floating lab in space, and it's really opening the door to a lot of new innovative technologies and missions.
But that's just the start for these solar arrays. In just a few months, the team at Redwire will be supplying 2 arrays for NASA's DART mission. You know, the one that's colliding a craft into the double asteroid Didymos. Check out our video on that here. Make sure to subscribe to Seeker for more rocket launch news. And as always, thank you so much for watching.
Yay, tardigrades!
Yeah, we love tardigrades. They're kind of cute. We think they're cute. And
They
also
are cute.
really amazing, like resilient little creatures. And they're going up into space finally, into the ISS.
That's awesome. Oh, I'm excited. I can't wait. These little things.
The significance of that is, you know, if the tardigrades can live in these really extreme places like space, then that means we can find life a lot more places than we thought, a lot more extreme places than we thought, which helps us with that whole finding life in other places thing that we were talking about earlier.
Yeah, and I know that like the just fact that extremophiles like tardigrades exist, these creatures that can live in the most insane conditions. We're talking super hot or super cold, acidic, really salty, really dry, all sorts of extreme conditions that, you know, most life that we think of can't survive. But the fact that there are these creatures that can survive that made us realize that the kind of what life could be and the environment that it could be in has definitely a lot broader than what we initially kind of looked at and thought about, which is just exciting. One step closer to aliens.
Tardigrades are also called water bears sometimes. So if you've heard about water bears, tardigrades, same thing.
Because they do. They look like little, with like what, 6 legs? 8 legs?
Yeah.
Hold on, let me see if I can pull one up. I know we've talked about them in the past. I talk about them whenever I can. Because they're adorable. Here we go. Look, that cute little tardigrade face. Looks like a little chubby, multi-legged bear that lives in water. They're adorable. Okay, so we just got another question. If we wanted to put a mini space station in orbit around the moon, how big could it be? One person, how long could it safely orbit? And that's actually something that is a part of the new Artemis mission. They are putting a space station in orbit around the moon to act as kind of a waypoint. So you would launch from Earth to that station, stay there a little bit. A couple of people would leave and go down to the moon and then come back up. And so really, I don't know. I'm trying to think. Constraints on size and stuff is not so much about, it's really about how fast it needs to orbit. So really, we could make it as big as we want. And I'm pretty sure that this one is meant to hold, I think, just 3 people. I might be wrong on that, though.
I mean, if we wanted, we could make it a full ring around the moon, like in 2001: A Space Odyssey. But this is like super exciting because all of these like sci-fi TV shows and books and stuff with those like space stations in the middle of space where they go and dock and get fueled up and stuff. before they go on. Like, that's going to be a real thing now, going around the moon.
Yep.
To help us prepare, hopefully, to get further out in space.
Yeah, because it is supposed to be also like our launching point to get to Mars, to send people there. They'd go to that station first and then launch from there to Mars. So it's exciting. We got a question about tardigrades. How long does a tardigrade live? And that's a difficult question to answer, because one of the things about tardigrades is when they are in conditions that they typically couldn't survive in, they have this ability to like almost dry themselves out, like dehydrate themselves, and go into a hibernation until they are back in an environment that they can survive in, and then they rehydrate and kind of come back to life. So part of these experiments with sending them up to space is really testing like how resilient are these things, because but in normal conditions, I'm not sure how long they live. Mm-hmm. They're crazy little space buggers. I love them. Yeah, I'm trying to think. Did you have anything else, Lindsay?
I do.
Do you wanna talk about that?
Sure.
Okay.
So I wanted to make sure to talk about this next thing because it's entirely possible that you have heard about this in the news.
SpaceX and NASA are teaming up again to launch.
Next slide. Okay. Yeah. So you may have heard that the oops, says my sharing is paused. It says my sharing is paused.
Weird. I see it fine.
Okay. So the Hubble Space Telescope has a computer glitch right now. So kind of some background information. So the Hubble Space Telescope was first sent into space kind of in the late 1980s. And so it had pretty old computers on it because of that. The last time, though, that they were upgraded was 2009. And we can't really upgrade the Hubble Space Telescope anymore because that was partly what the job of the space shuttles were. So the space shuttles were made to carry parts up to help fix like things like the Hubble Space Telescope, also to help build the International Space Station. But now that the International Space Station is mostly built, and the Hubble Space Telescope was built, they didn't really need those space shuttles anymore. And so that's why we don't have the space shuttles anymore. So for this particular computer glitch, it is luckily computers from 2009 and not the 1980s. But there's still obviously a problem that they're having. So luckily, there are actually two different payload computers in the Hubble Space Telescope in case one has a glitch. So they haven't gotten the backup one up and running yet, though, because they want to make sure that they know exactly what the problem is. And so when they go to do or start up the backup computer, they don't ruin anything else. Or if they go and start the backup computer and that wasn't the actual problem, or there are more problems, they know that before they start to try to go and start up the backup computer. And so scientists at NASA are pretty confident that the Hubble Space Telescope will be up and running again, but they just want to be extra sure they are fixing it correctly, because we don't have a way to go to the Hubble Space Telescope to fix it again like we did when we had the space shuttles.
And I will say, I mean, the Hubble is getting...
It's 30 years old.
Yeah. It's lasted longer than a lot of people thought.
Yeah, way longer. I'm hoping that one positive outcome of this is that it will get the people working on the James Webb Telescope to kind of get moving and get that telescope up into space so that we can start using that too.
Yeah, because that is Hubble's kind of successor. Yeah. So Cool stuff. But
Uh,
that is a part of having telescopes in space, though. I mean, unfortunately.
yeah, they're a lot harder to access, but they get much better pictures because they don't have to look through the atmosphere.
Yep.
So the Juno spacecraft has actually been going around Jupiter for 5 years now.
Did you change? Because nothing changed on the screen.
Okay. Maybe I'll try to stop sharing.
Yeah. Because I want to make sure I see Juno pictures. There we go.
Okay. So the Juno spacecraft again has been going around Jupiter for 5 years now. I mostly just love looking at the pictures that Juno sends back, and actually we can learn so much about Jupiter just by looking at the pictures that it sends back. They're so high resolution. So these are some pictures of Jupiter's atmosphere that were taken in early June. And it's just amazing to me how, like, yes, we can see, you know, the stripes, the wind belts that we've always been able to see. We can see these oval things that are storms on Jupiter. But then if we look real closely, we can see all this extra little turbulence in the atmosphere, and it's just so cool. This big red spot over here is the Great Red Spot. All of these little ovals are hurricanes, actually, on Jupiter. This Great Red Spot is about the size of 3 Earths. Or is it down to 2 now?
I think
know
it's down to 2 now.
So it has been changing, but it has also been going since the 1600s when Galileo first saw it nonstop. Because Jupiter has such a windy atmosphere. Also, these hurricanes don't have any land to run into like hurricanes do have here on Earth. So the hurricanes here on Earth that run into land, that's partly what slows them down and helps make them stop. There's nothing like that on Jupiter. And so these hurricanes can last a really long time.
Yeah, and even though it's getting smaller in size, I believe I read a report about a month or so ago that said that its strength isn't decreasing, which is interesting. There's still a lot for us to learn about how these storms work.
So here's kind of a panorama of a similar picture. Also, we were talking about citizen science earlier. Juno spacecraft is another place where citizen science is helping out because Juno's taking so many pictures of Jupiter that they put the raw data that Juno has of Jupiter's pictures, and they put them up on the Juno website, and then other people that know how to process astrophotography images can actually do that themselves. So this one was actually processed by a citizen scientist.
And Mars has the same thing. You can do the same thing with like pictures from Perseverance. In general, NASA's really great about putting up all of their raw data and raw images for anyone to access and do stuff with.
Yeah, most of NASA's data and pictures and things are public domain. So.
Yep.
Okay, the one that I was really excited about was Ganymede. So this is from last week. The Juno spacecraft did a flyby of Ganymede. Previous to this flyby, the last flyby of Ganymede was actually the Callisto spacecraft that went out to Saturn. And then prior to that, it was all the way back to the Voyager spacecraft that left the Earth in the 1970s. It was the first time we got an up-close view at Ganymede to kind of see what it looked like on its surface. Ganymede is one of the Galilean moons. There's 4 of them. Galileo saw this moon as a little tiny dot in his telescope back in the 1600s. But again, with that Voyager spacecraft, we finally got to get a close look at the surface of Ganymede. And I mean, again, Juno is just providing such high resolution images. It's just really amazing. So you can kind of see some lines on the surface of Ganymede in addition to some craters. And so scientists think that the surface of Ganymede is kind of icy. And so those kind of lines are kind of cracks in the ice that get filled in. And then of course the craters are from things running into the surface of Ganymede. Just another really pretty picture. You can see also the upper left area of Ganymede is a little bit more cratered than the bottom right. And so that's another reason we think that maybe it has an icy surface. There would have been some water that kind of flowed up on top of the surface of Ganymede and covered some of the older craters down here in the bottom right and not up here in the upper left. Just another really cool up close pic of a crater. This is another picture that was done by a citizen scientist. Just again, really amazing photos.
Yeah, I would say this is a problem we have when we get all sorts of new data is we just want to show all the pretty pictures. Like, it's just amazing.
And there's so much more that we can learn about, Ganymede now that we have, higher resolution images. That's my last one.
Very cool. All right. Well, I know that we have gone a little past our half-hour time. So unless we get any more questions, I think we'll start to wrap things up. But there is one more thing that I wanted to show everyone, because it's something that we have been working on here at the Planetarium and are really excited is going to go live very soon. So we have an all-sky camera placed up at the end of the Gunflint Trail at Chickawauk Museum and Nature Center. This location is picked, one, because it's awesome, but two, because it is incredibly dark skies. We're talking like level 1 dark skies, the darkest you can get. And so by having this all-sky camera there that can show us what the sky looks like, we get these magnificent, oh my god, I can't speak, magnificent night sky views. But also we get pretty auroras and all sorts of things. So I have been working in collaboration with the Gunflint Trail Historical Society and the Chickawauk Museum and Nature Center. And so we have this camera that is up and going. This video at the beginning, you're seeing me playing with settings. That's why it kind of flashes around a little bit. But here is a sequence that we got from the other night. And one thing I want to point out, this really bright picture, this really bright thing right here, that's the moon. I don't think people, and even I sometimes, forget how bright the moon really is. And so you can see as the moon finally starts to set, just how much darker it gets. We can see meteor flashes, satellites we could see if they're going by, and now we can see the Milky Way, see the whole sky turn as the Earth rotates, and then the sun comes up and we're back to daytime. But I just wanted to share this with everyone because we are hopefully going live with this in a couple of weeks, where we will have a website up that you can go to that will show the most current image from the camera. We'll have all the archives of the images that it's taken, these time-lapse videos that it's taken, and we are just very excited to finally have this project going live very soon. We've been working hard on it. So yeah, you can expect the full announcement on that coming up in a few weeks, I would imagine. Just a few things left to do with it, and then I'll be ready for everyone. All right. Well, I'm not seeing any more questions. So Let me tell you guys what's coming up over the next week, and then we will head out for the night. Saturday is the next in our exploration series, where we're going to take an up-close look at the planet Venus. And then next week, we are at the beginning of July, believe it or not. So we will have the What's Up July edition on next Wednesday to look at the astronomical events taking place. And then next Saturday will be the July constellation story time, where we'll look at the stars and constellations that are up and the stories behind them. All right, well, I think we will wrap it up there. Thank you everyone so much for joining us and for your awesome questions. I think that's one of the things we love most and why we continue to do this Ask an Astronomer segment is you guys bring us some amazing questions, and I feel like I even learn stuff every time we do this. So thank you. We will do one of these again soon, I'm sure. But have a wonderful rest of your evening, and we will see you again next time. Bye, everyone.